go what? Center. Beautiful. It is center. A circle is named from its center. Now, the next one states the following. A blank is a segment that has one endpoint on the center and the other endpoint on the circle. What is that called? Radius. Perfect. All right. And a blank is a segment that goes through the center and both endpoints are on the circle. What is that called? Diameter. Good. Now, this is the one that might be new. It's a central angle. It's an angle whose vertex is in the center of the circle. Central angle. Okay? Now, stop. Technology is not working today. All right, let's just go through it. The sum of all the central angles, and I'm just going to show you a picture. If I have a circle, the computers are acting up today. Good luck on if this is going to record or not. All right, if I have a circle, look at this circle right here. We're just going to go here. All right? If I add up every one of those angles, because each one is a central angle, okay? They would add up to 360 degrees. So the circle is 360 degrees. So the sum of the central angles in a circle is 360 degrees. So, if I look at this, I have all these angles here. If you were to add up every single one of those angles, it comes up to 360 degrees. Okay? Now, we're going to get to, pause 1 second. Let me pause the video. I'm going to try to get my stuff back. Sorry, y'all. Computer technology is not. What's my thing?
Yeah.
You with me? An arc is basically the crust of the pizza. Everybody with me? Because the circle is really the pizza. The inside where you put is really the crust. And the inside part where you put all the toppings is not really the circle. It's just inside of it. Okay? The circle is actually the crust of the pizza. So, look at this. We're going to do some examples. Let's see if my picture will work. Oh, it's working now. Yay! I'm going to make this.
You just jinxed yourself.
T. You already have this written down. Does everybody see this?
Yeah.
S U Q. All right. Name a radius. Let's name all the radius that are on here. Someone name the radius. Name me a radius. I see QG. I heard GR. GF. GT. And GU. The key is they go from the center to a point on the circle. Is everybody with me? Now, name me a diameter. Hold on. diameter, I heard RT. And what else? US or SU. The key is it has to go both endpoints, and it has to go through the center. All right? Now, name the circle. How do we name the circle? By its what? By its center. What is its center?
G.
So this would be circle G. Just like that. Name a central angle. So name me an angle whose vertex is in the center. Remember, you need how many points to name a circle? Name an angle. 3. G. If you do GRS, you're talking about this right here. What are we talking about? RGT. It's talking about this whole angle. That is one. RGT. Give me another one. UGT. UGT is talking about this angle right here. I heard another one. What did you say, Anna? SGT. I like that one. SGT. That will talk about this angle right here. What is the key? What does that middle letter have to be? What does the middle letter have to be in order for it to be the? It has to be the center of the circle. Yes, that is your vertex. Remember, the middle letter is your vertex. All right, now let's talk about parts of an arc. This is where I can come back in now. Now, there are 3 types of arcs. There's a major, a minor, and a semicircle. Okay? In a minor arc, the degree is less than 180 degrees. All right? You name it by 2 endpoints. And here's an example. I have this circle. AB would be a semicircle. Would be a minor arc, A to B. Do you see that that is less than 180 degrees? Does everybody see that? What's 180 degrees? It is half of the circle. Now, the angle is equal to, the measure of the angle is equal to the central angle. Okay? Now, a semicircle is exactly how many degrees? It's a semicircle. 180. It's half the circle. It is named by 3 points. Here's an example. ABC is half the circle. So the way that I would say this is I would say A, B, C, and put an arc over. This one would then A, B with an arc over. How many degrees is a central angle? A central arc or a semicircle? You up? Oh, okay, good. 180 degrees. Now, y'all know I love y'all. Now, a major arc is more than 180 degrees. It is named by 3 points. Here's an example. What? Yeah. Why not? Yeah. B, C, D. Do y'all see that that is more than 180 right there? And it's one of two things. It can be 360 minus the minor arc, or you can add the minor arcs together to get your angle. Now, I know that probably doesn't make a whole lot of sense, but we are going to practice. Okay? Does everybody have that? Andy, you have it? All right. Now, let's go over this real quick. This should be the next, right? I see that mine has been cut off. So, if I look at this, it says, do me a favor, Miss Tips, hit the lights for me. When you see the M of AB, that means the measure, is Andy going to be able to stay away? Of arc AB. So if you look at this, look at my arc over here. If I took AB plus arc BC, okay, arc AB and BC, they would equal the measurement of what arc? AB and BC. If I add those together, what arc would that measure up to be? ABC. I can add those together to get the full arc. It's almost like angle addition or segment addition. So let's look at this. Let's name some minor arcs here. Can someone name me a minor arc? B, right here, on this one. Wrong one. QU. Look at that. That's less than 90 to 180, right? So QU. Give me another one. What did you say? US works? What else? How about RS? QR? How about this one? Is this a minor arc? How about RU? Is R to U a minor arc? It is because A, I only use two letters. I can't go the opposite way because that would make it a major arc and it would need three letters. Okay? Give me a major arc here. RSU. Now, if she said RSU, I cannot go this way. I have to go in the direction that she told me. R to S. So R to S to U. Yes, that is a major arc. RSU. Give me another one, somebody. QU to T. Would that give me more than 180? QU to T. No. QUS. Would that give me more than 180? No, it's exactly. How about QUR? Let's look at that. QU to R. Yeah. Now, you all should all know semi-circle now. Give them to me. Give me one. A semicircle. RST is one. Like it? Give me another one. Q what? QUS. Because you're going from Q to U to S. Yep, that's it. Give me another one. RUT. And then what was the other one that you just said? RQ to what? Does that get all right. All right, beautiful. Now, look at this. This looks like a whole lot. It looks like a lot that we don't know. But do not look at this over here first. Let's fill in our circle. first of all, we have that this is 158, this is 90. Can someone give me some other, we need to figure out these two right here. Tell me how am I going to figure those out? Mm-hmm. Which one? For Q, from G to R, what would that be? 90, because I heard it over there. If this is 180 degrees, right? I subtract 90 from it and I get 90. Someone tell me how I could get this angle. It's a couple things. I heard I could subtract 151 from 180 and get 29. The other option I could have done is I could have added all these up and subtracted it from 360. Because it's my last angle that I have. Now that I know all this, I have enough information to solve this. I am going to do number 4, number 7, and number 10, and you're going to do the rest. G, J. What is it from G to J? 90 degrees. Beautiful. What about G, J, I? So I'm going from G to J to I. How would I solve that? What would that answer be? How do you get it? I'm adding 90 and 151. And that becomes 241. Beautiful. All right? Then it says H, G, H to G to J. 180. And then I will do 13, then you're on your own. You ready? H, J, H, J, I. Now some people say, well, why can't I go this way? Well, then you already covered I. You have to follow the direction, see which direction you need to go. H, J, I. So H to J, and then to I. Give me two ways I could have done this. What's one way I could do this? Add them up, 90, 90, and 151 was another way. Yep, 360 minus 29, because that's the only spot that's not there. And what's my answer? 331? All right, you got the rest. Go for it. I think I wrote it over here. A circumference of a circle is the distance around the circle. It is the length around the circle. Circumference. I love food, so let's talk pizza. Circumference is if you were to say, if I was to put a large pizza right here, boom, and they ate it, but none of them liked the crust. Okay? So what we do is if I was to take each person's crust, all 8 slices, and line them up, Andy, the length of the crust is the circumference. When you think of circumference, think of crust. Think about it. The length of a large pizza's crust should be longer than the length of a small pizza, right? Because it's a smaller pizza, so the crust is going to be different. So the formula for circumference. Does anyone remember what it is? Y'all be like, oh yeah. 2 pi r. Or you could do pi d, which is diameter. R means radius, d is diameter. Now, that is for the whole pizza. But what if I only wanted to find the length of 2 crusts instead of all 8? That would be a fraction of the circumference. So that is the arc length. If I'm just asking for the arc length. I'm not asking for the whole pizza. I just want a portion of the pizza. Andy! If you don't wake up, I promise you. Throw that up. Alright, so when we find the arc of a pizza, if we just find the arc length, what we're doing, we're taking a percentage of the pizza. So it's the degree over the whole pizza, which is 360 degrees, times 2 pi r. So if I wanted 90 degrees, that's only a fourth of the pizza. So 90 over 360 times the radius, times the whole circumference, will give me that portion. It's a fraction of the pizza. Now, we are going to practice it. Once we practice it, then you're going to your work. So let's start first with just finding circumference. I always just use 2 pi r. We're going to leave this in terms of pi, and then we're going to multiply this out. So if I leave it in terms of pi, first of all, what is my radius here? What's my radius? 16. So, if I was to solve this, it would be circumference is equal to 2 times pi times 16. If I tell you to leave it in terms of pi, the answer would be 32 pi. Which means when you leave it in terms of pi, you're not multiplying the pi out at all. Just leave it just like that, 32 pi. That is the exact value. Now, if I wanted a decimal value, everybody knows what pi represents? What's the number for pi? 3.14. So you would take your calculator and do 32 times 3.14, and someone tell me what you would get. Say it again. 100.48. If you would have put 32 times 3.14 in your calculator. Is everybody with me? 32 times 3.14. Now, let's look at number 2. What is my radius here? 11. Does everybody see why it's 11? This is the diameter. So my radius is 11. So 3 times 2 times pi times 11 would give me 22 pi. If I wanted that in decimal form, it would be P is equal to 22 times 3.14. And someone tell me what that would be. What is 22 times 3.14? 69 point what? 08. Now, I want you to do number 3. Go for it. Times pi times 6.8, which you should have gotten 13.6.
Yeah.
Pi. 2 times 6.8. Now, if you put it in, it's going to be 13.6 times 3.14. What'd you get there? 42.7. There's your answer. Is everybody with me? All right. Let me get through these two. Now look at this problem. I want you to read it and tell me what they gave you. I want you to read it. Just read it to yourself. Underline any information they gave you. All right. What key information is in here? The circumference. So, if they say circumference. I know the formula for circumference is 2 pi r. Did they give me the radius? No. We know what pi is. Did they give me the circumference?
Yeah.
Oh, they gave me the circumference this time. So we're going to work our way backwards. So the circumference is 10 pi. And we're looking for the radius. Well, here's the cool thing about it. I know y'all looking like this math is so crazy. If you have a pi on both sides, they're going to cancel out. Now I just have 10 is equal to 2r. And if I'm solving for radius, how do I solve for radius here? What do I need to do? Divide by 2. So radius is 5. I'll call her. Radius is 5. So the diameter would be what? 6. The diameter is 2 times the radius. How many more do I have? And I'm going to give you your break.
Keep going.
1. Yep. And then we're going to go to break. All right. Go ahead and set up number. Go ahead and. Oh, I did that one. Oh, it should say 30, right? Go ahead and solve. Put that one in an equation. Go for it. So, circumference is 2 pi r. They tell you the circumference is 30. Oh my goodness. I don't have any pi's to cancel out. But what does pi represent? Oh.
Oh, I didn't do that.
So, can't you tell me what 2 times 3.14 is?
I did that one.
What is 2 times 3.14? 6.28 r. Can't you all solve this for the radius now? How would I solve this for radius? Divide by 6.28. What is my radius here? What is the radius? What is it? 4.7. What would be my diameter? 9 point what? There you go. All right, let's go for this time. All I want to know is what is the circumference right there? Is everybody with me so far? So, let's find out, if I was to tell you to find circumference, what would your formula be? How would you set this up? 2 times pi times what? 9. Okay? Is everybody with me? That would be the whole circle. But they don't want the whole circle. What percentage do they want? What degree of the circle do they want? They want the 20 degrees out of the whole circle. So you're doing 20 divided by 360 times the circumference. So it gives me only that portion. So in your calculator, this is what you put. 20 divided by 360 times 2 times 3.14 times 9. And then enter. Did you get 3.14? Because that is 20 degrees of the 360. Everybody needs to punch that in your calculator right now. I gave you the answer, but you need to punch it in so you can practice. 20 divided by. Write it all in. You don't need to wait for me. 20 divided by 360 times 2 times 3.14 times 9. All right. Now, if you have this shaded in, please do not shade it in because we're not talking about the area. We're talking only about the crust. Okay? Now, let's look at the next one. So, real quick, if I was talking about circumference, it would be 2 pi times, what is my radius here? 7.5. How do you get 7.5? You take 15 divided by 2. Because 15 is the diameter. Now, are they talking about the whole circle or what degree of the 360 am I talking about here? I'm only talking about 120 of the 360. And there's your formula. 120 divided by 360 times 2 times 5 times 7.5. Did not call it out. Everybody put it in your calculator. Did not call it out. Everybody put it in your calculator. Come on, Jason. In your calculator. You're putting it in order. That's not how you have it written. I have 120 divided by what? Put it in there.
Tuesday, Monday.
Time. That's going to represent. You've only done it 4 times in there. So there's the top. You switch pi with it.
What's the number one top one?
3 what? All right, your answer should be 15.7. Did everybody get that? All right, so you all have the other part to do on your own. I wanted to go over this problem on the next page, just so that you can have an example. Everybody with me? Look on the next page. I'm just skipping, but it's in the next page. This is problem number 2. This is the measurement of all the degrees. What do all the central angles add up to? 360. So in order to solve this, and you might need more room, I have to do 20a minus 30 plus 2a plus 4 plus 10a plus 2 is equal to 360 degrees. I had to add them all up to equal 360. So this is 20 plus 2 plus 10 is 32a. Then I have negative 30 plus 4 plus 2 is negative 24, which is equal to 360. Let's add 24 to both sides. 32a is equal to 384 divided by 32. What do you get A to equal? 12. So that should help you on the other ones. All right?